Okay, let's do this. I'm going with it. Here we go. All right. First half of this unit is surface area and lateral area, which I'll get to today. And the second half is volume. So you're going to see these figures twice. Today, you're going to see cylinders and prisms, and then you're going to see them next week when we talk about the volume of them. All right. Before I get into that, though, a couple just new vocabulary terms. The polyhedron, we're going to talk about three-dimensional figures this unit. Not rectangles, rhombuses, trapezoids, which are two-dimensional figures. These are going to be three-dimensional figures that have length, width, and height. There are a couple pieces I'd like you to be familiar with. There are three different pieces to every polyhedron we're going to go over. One is called a face. So let me just highlight, this is a face of a polyhedron, okay? A face of them. Then you have edges. Edges are what connects a point. So let me highlight an edge. Here is an edge, GF. And then finally, you have vertices, which are the points. All right, so H is a vertice. Okay, H is a vertice, G is a vertice, C is a vertice. So what I did up here is I created three polyhedrons, and what I would like you to do is, can you identify how many faces, how many edges, and how many vertices? All right, so let's do this first one together. How many faces are on that first polyhedron? Everyone agree? They got a top, bottom, front, back, left, and right. There's 6 of them. All right, be careful now with the edges. And yes, we do count the dotted lines as edges. It's dotted because it's kind of in the back. All right, not seen, but we have to count it. So how many edges for this polyhedron? I have 12. Everyone 12? Counting them up. I know they're a little crazy to count up. Sorry, edges, not vertices yet. Okay, edges, you got 12. And now how about vertices? Should have 8 vertices. Yep. We all right? Some of you guys getting ahead of me here? All right, can I start calling on you guys now? How many faces? Anybody know what this polyhedron's called? We'll talk about it tomorrow. Pyramid. Yep, it's a pyramid. All right, how many faces in the pyramid? Actually, I'm not even going to try to call them. What do you got for me? How many faces? 5 faces. I only see 4. Got to count the base. Remember, got to count the base. So 5. How many edges in the pyramid? There should be 8 edges. And how many vertices? 5 vertices. Yep. And number 3, this is what we're going to talk about today. This is called a prism. A prism. How many faces? 5 faces. Edges? Woo. 9. And vertices? 6. Now, could it happen you forget to count one? Absolutely. Here's a way to check any polyhedron if you have the correct number of vertices, faces, and edges. All right. So to check, and a mathematician came up with this check, the number of faces plus the number of vertices minus the number of edges. So if you add your faces, vertices, and subtract your edges every single time, every polyhedron, you're going to get the number 2. Test it out right now. Test it out. Pick one of our polyhedrons. Test it out. Faces plus vertices minus edges, is it always 2? Every time, ladies and gentlemen, every time. So if you want a quick check, I don't know if I counted the number of vertices or edges especially right. Make sure it fits into the check. All right? Faces plus vertices minus edges equals 2. Questions on that part at all? Okay, next part before we actually start finding some areas. Cross section. This is a pretty big topic, not a big topic, but it will come up on the Regents exam guaranteed. Cross section. You take one of these polyhedrons, slice it, hold it up. What figure is it? All right, and it depends on the polyhedron, depends on how we slice it. All right, so for example, I got a cylinder here, and what I did was a horizontal slice. All right, I took my plane, I sliced it horizontally. I hold it up to you. What two-dimensional shape would it be? A circle. So we could say a cylinder has a cross-section of a circle. But is that the only way to cut it horizontally? No. How else could I cut it? Vertically, and that wouldn't be a circle anymore. Think about a cylinder. I go my plane right down. I turn around, I hold it up to you. Anybody know what it's going to be? It's going to be a rectangle. And me holding my hand up here is not the best visual, all right, to show a rectangle. That's why you got your Chromebooks out. If you could right now, take a minute, go to this website. We're going to visually do some cross sections right now for different figures. All right. So go ahead, go to that website. Hopefully I can too. GeoGebra.org. And we're going to play around with some polyhedrons and take vertical and horizontal cross sections. Maybe we can predict what's going to happen. Thought this was the easier way than just trying to Google it. Everybody good? We get there? Leave it up. Let me know, Emily. Okay, all good? Okay, let's play around here a little bit. Let's play around. Let's go to that cylinder. So over here on the left, prisms and cylinders. And we'll just go right to sections of cylinders, what we were just talking about. All right, so everyone see how they just did a horizontal cross section here? You can click on view from the section and it'll show you the cross section. It's a circle. Okay, it's a circle. Now let's say if we want to do a vertical one. All right, everyone see where it says horizontal vertical up here? You can slide it over to vertical and view the cross section and it'll show you it's a rectangle, just like we predicted. Okay? All right, what else should we try here? Go back to prisms and cylinders. Want to try a rectangular prism? So rectangular prisms. And you guys can play around here. All right, let's see it. Here's the rectangle for horizontal. What's it going to look like vertical? Whew. Another rectangle, a little bit skinnier, but okay. Can we go to cones and pyramids real quick? Can we go to cones? An interesting one. So go to sections of cones. So everyone see we got a horizontal going right now. What's that going to be? A cross section of a? That's definitely a circle if you want to take a look. There's the circle. What do you think it'll look like when I do a vertical? Oh, really? Let's see. There you go. Nice job, guys. Nice job. Let's see. Can I get other different? If I wrote, go in between like a diagonal cut, maybe. If I go in between horizontal and vertical, a diagonal cut. Got a little circle. Whoa! Look at that, huh? The closer you get to a vertical one. Okay. Okay, the closer I get to a vertical cut, the more it'll look like this shape right here. Okay. And sphere, what do you think for sphere, no matter how we cut it? You think it's always a circle no matter how I cut it? Yeah, it looks like it. It's always going to be a circle. Yep. All right, so are we getting the idea of a cross section here? It could be, no matter what the shape is, it could be different depending if I do a horizontal, vertical, and you guys just saw on the cone a diagonal one. Okay? And if you ever want, I don't know if you want to pin this and cheat on the homework anytime for cross sections, it's up to you. All right, speaking of cross sections here, let's answer some questions here. Which figure up here can have the same cross section as a sphere? Well, what did we just find out? No matter how we cut the sphere, what's the cross section always going to resemble? A circle. So out of these figures I have up here, which one could I do a cross section that will result in a circle? And that would be the cone, choice 2. That's the only polyhedron I can cut that I'll get a circle in. Okay? So that'd be the cone. And speaking of the cone, which drawing cannot be a cross section of a cone? So if we can go back and look if you want, but as we did vertical to horizontal, vertical to horizontal, vertical to horizontal, we would not come up with one of these as a cross section. Anybody remember which one? Square, yep. Because remember, hey, the circle was a horizontal cut, the triangle was a vertical cut, and then we saw this arch here as we went diagonally. All good on cross sections because I'm going to drop it there. I just wanted you guys to see it visually. I thought that was a good website to go to. All right, here we go. Today's first one, prism. Prism. Here's the part I need you to remember. A prism has 2 parallel congruent bases. 2 parallel congruent bases. And that's how you name it. What are the shapes in that prism I have for you that are parallel and congruent? Parallel and congruent. Those are what? Those are pentagons. Everyone agreed the bases are pentagons here. All right, so the bases are pentagons because those are the 2 parallel congruent shapes in that diagram. And I would name it by the base. So we'd name this, ready to get fancy, pentagonal prism. All right, pentagonal prism. That's going to be huge. See, I'm not going to gloss over that. That is going to be huge today, is that you can identify where the bases are of a prism. All right, where are they? 2 types of prisms. A right prism, this is what we're going to be dealing with most of the time. A right prism, it just shows you that the edges are perpendicular to each other. Okay, that's what a right, versus an oblique prism, it's got a kind of slant to it. We really won't be working with any oblique prisms. All right, but right prism, the edges are perpendicular. All right, have you guys heard of these terms before, lateral and surface area? Yes? Okay, let me start with surface area first. Anybody surface area, you want to explain it to me then? No? It's area of something. It's area of everything. All right, it's the area of all the faces. All right. And I'm not going to give you a formula for it. You take each face, find the area, and add them up. That's what we're going to do today. All right, find the area of each face from last unit and add them all up. Okay, how's that different from lateral area then? Ready? Lateral area is not all the faces. Take away the bases and add the area of what's left. That's lateral area, is everything minus the bases. Okay, everything minus the bases. So the lateral area is the area of all the non-bases. So we're going to take a figure, we're going to plop off the bases, find the area, that's the lateral, put the bases back on, that's the surface area. Everyone see the difference there before you start finding the different areas. Surface area, everything. And then take off the bases, you got the lateral area left. All right? Whew. All right, let's get going. Find the lateral area, then the surface area of each of these prisms. Anybody want to name number one? What type of prism would number one be? Name it. Rectangular prism. Now, some of you may be staring at this and having an issue. I have a big issue right now. Because remember what the bases were? Those were the two parallel congruent sides or bases. If you take a look. Aren't the left and the right parallel and congruent? Aren't the top and bottom parallel and congruent? And aren't the front and bottom parallel and congruent? So what the heck do I call the bases if I have three sets of those? Everyone ready for the general rule when it comes to a rectangular prism? How it's drawn, the top and the bottom will be the bases. Okay? How it's drawn, the top and the bottom will be the bases. So what are the bases here? Your 10 by 3 rectangle. Okay? If I turn it up on its side, now it would be your 3 by 3 square here. Okay, everyone good? So a rectangular prism only, the bases will be the top and the bottom, how it's drawn. All right, lateral area, here we go. Find the area of everything but the bases. So give me the front, give me the right and left dimensions right now. The right and left faces, what do you got for me? 3 times 3, and how many of them are there? 2 of them. So 2, 3 times 3. That takes care of the right and the left. What about the front and the back now? Front and the back. 10 by 3, and there's how many? 2 of them. And I'm doing lateral area, so I'm not counting the other 2, the top and the bottom. Lateral area is the area without the bases attached. So go ahead. The lateral area for this rectangular prism. What are you coming out? 78. Yep. And area. Justin, tell them again. Square units. Okay. Don't leave those off. You guys did a nice job on your quiz remembering those. Okay. Surface area. Part B now. Find the surface area. We already did some of the hard work. Do I need to recalculate everything again? No. I'm going to take that lateral area, 78, and now what am I going to do? Find the bases. Add the bases in now. And what are the dimensions of the bases? 10 by 3. And again, how many of them are there? 2 of them. There you go. I don't need to find all 6 again. All right, I just found 4 for the lateral area. I'll just bring it down into the surface area. And that'll end up being 138 square inches. Also, just a little common sense check. Which one should always be bigger? If you're adding on the bases, surface area should always be bigger, yes. 2, identify what shape are the bases? Triangles, name the prism then. This is a triangular prism. So everyone ready? Take the triangles off now. Take the triangles off. We're going to find the lateral area. Once you take the triangles off, how many faces are we dealing with? How many faces am I going to find the area of? 3 faces. All right, let's do the bottom face. That's a what by what dimension here? 12 by 16 for the bottom one. Can we go to the one to the left now? Face to the left. That's a what by a what? 9 by 16. Lose anybody yet? And I purposely left this one for last because what's the one to the right? 16 by, not labeled for me. Not labeled. 16 by, little help. I can do what here? Pythagorean Theorem. It never leaves, ladies and gents, never leaves. 9 squared plus 12 squared equals c squared. What do you got for me? What's that side length there? 15? So it's going to be 16 by 15. All right, there's your lateral area. And your lateral area, 576 square inches. Nice job. All right, now we're going to take that lateral area of 576 and add in what now? Oh, the bases, which are, what'd you tell me again? Where are the bases? Triangle, back it up to last unit we just finished. Half base times height. And you have how many of them? And they're always congruent. So I can always multiply by 2 because there's 2 triangles congruent. All right, help me out then. 576 plus 1/2. Oh, right triangles. What are the base and the heights here then? Legs of 9 and 12. And again, I have 2 of them, so multiply that value by 2. And I don't know if you guys see what happens when you multiply a triangle formula by 2. The 1/2 and the 2. See ya! So it's just base times height. Oh, I can't. I'm getting jacked up about this last problem. 684 square inches. All right. Oh, whoa, whoa, champs. Everyone all right on the prisms? Because I got a special prism for you now. A prism where the bases are circles. Also known as a cylinder. So it's just a cylinder, just prism with circular bases. They don't give. Sorry, I thought maybe this was on your formula sheet, but it's not. All right. So lateral area. Let's talk lateral area first. You guys are enriched, right? Describe to me what lateral area is of any figure. That's the area of everything but? Okay, so I took the circles off. Okay, the circle's off. So here's my lateral area. Everyone agree? There's the lateral area. I cut it, open it up, it forms a. Okay, let's keep going. What is the area formula for a rectangle? Okay, let's go back. Ready? This right here is one side of that rectangle. What did it represent in the cylinder? Here you go, ready? There's one side of my rectangle. What did it represent on the cylinder? It's height. Okay, so I know the height of the cylinder is going to be involved. So something times height. Here's the tough part. Everyone ready? This part up here. This distance right here. What did it represent? Circumference. Nice. Area formula for circumference back in the day. You just found the lateral area of a cylinder. Pi dh. Circumference. Height. Circumference. Height. Okay, there's the lateral area. Now I know you can do it without my help. Surface area is when I take this lateral area and do what now? Add on the 2 circular bases. I add on the 2 circular bases to the lateral area. Finish that formula for me then. Add on the 2 circular bases. Finish that. Pi r squared, but 2. Nice job. 2 pi r squared. Yep. Lateral area plus the 2 circular bases. All right, I want to fly through these a little bit so I can get to this last problem. That's a beast, and I'm going to love it. Cylinder. Lateral area of this cylinder. Pi dh Diameter, 10. Okay, now I know you're just going to plop in a 2 because it's the only number there. The height, hey, I've got to stress this big time. The height is the distance between the circles. All right, it might be hard for some people to find the height, but the height is the distance between the circles. And yes, in this case, it's 2, the distance between the circles. And nearest 10th, let's roll. 62 point. Yep. Units, units, units. Good. Here we go with force, lateral area. You see what I mean by the height is the distance from the 2 circles. So pi, what are you plugging in for d here? Not 3, but 6 times 6. And what do I have here? 113.1 square meters. Yep. Ooh, leave your answer in terms of pi. Love it. Love it. Here we go. Surface area now. Surface area. Pi dh plus 2 pi r squared. Diameter, 2. Height, 3 plus 2 pi r 1 squared. Yep, be careful here. I always get nervous when you use this because you got one side you use the diameter, on the other side you use the radius. 6 pi. And over here, 2 pi. Leave your answer in terms of pi. Don't touch that pi button. You're better than that. Can I combine those two? Yeah, as long as both have pi's in them. So this will be 8 pi meters squared. All right, go ahead. Try 6 on your own here. Try 6 on your own. Leave it in pi, leave it in pi. Different answers here in terms of pi. Different answers. We don't want to try it. Justin, let's roll, stud.
94.5 pi centimeters squared.
Other versions? I'm not saying that's right or wrong. Yep. 84.25. Okay. Anybody want to add a third version? What do you guys have? Pi times 7 times 10. There's your lateral area, right? And then you added that to 2 pi times 3.5 squared. All good so far? What'd you get here? 70 pi. What'd you get here?
24.5.
I have 24.5 pi. 3.5 squared times 2 should give you 24.5. And then you add them together, and yes, you get 94.5 pi centimeters squared. We okay there? Plug in everything. That's just a plug and chug, really. All right, we ready to get after it here to finish this off? This may take us the rest of the period. If not, oh, we got some Regents questions to do. Here we go. Love these. A figure on top of another one. And I'm asking you for the surface area. Now, whoa. This isn't as easy as I'll take the cylinder, add it to the cube, I'm done. No, absolutely not here. Surface area is everything on the outside that is showing. That is showing. I cannot count something that's covered up. All right, I cannot count something that's covered up. Let's do the cylinder first before we go to the cube. Is every single face of the cylinder showing? No. What is being covered up? One of the circular bases. So I cannot count that in my surface area. Watch. So let's do the cylinder first. And you guys know surface area, pi dh plus 2 pi r squared, but I can't use that formula. What did you just tell me was covered up? One of the bases. So really, I'm going to do pi dh plus, thank you, pi r squared. Does everyone see that? Why I'm not including the second base? Because the darn thing is being covered up by the cube. Surface area is everything that is showing on the outside. All right, let's get to work here. Pi diameter, 4 times your height of 4, plus, be careful with your 4s here, radius, 2 squared. I'm just going to leave this in terms of pi for the time being. 16 pi plus 4 pi. 20 pi right now, okay, before we get to the cube. So is everyone all right with the cylinder? Everyone see what I'm trying to get through here? You can't count something that's covered up. All right, we got a little bit different ball game going with the cube now. Are all sides showing on the cube? No. Give me how many faces are definitely showing, though. 5 different faces are definitely showing. Everyone agree? Okay, let's at least find that then. 5 faces showing. What are the dimensions of each of the faces? They're all the same. They're all 5 by 5. So 5 faces, they're all 5 by 5. What's the deal with that 6th face? And how can I find how much area is showing? You can do it. How can I find how much of this area right here is showing? Let's go, Mike. Suggestion. Okay, so let's go there. So Mike's saying, all right, add on. What's the dimensions of that whole face? Whole face. 5, so 25? 5 by 5. But what do you have to subtract out? What's on top of it? A circle. And what's the area of a circle? Minus pi. What's the radius of that circle? 2 squared. Everyone with me there? 5 faces definitely showing, but the 6th one is going to be the face minus the circle that's on top of it. All right, so let's calculate the cube and add it to the cylinder. There are no rounding directions, so I'm going to write out my full calculator display. Just so we're on the same page, what are you guys getting for the cube? 175? No? Or sorry, that's the final answer. How about 112? 0.5663706? No? Yes, no? No? Oh boy, one job. Calm it down, boss. 125 plus 25 minus 4 pi. Oh, 137. Look at that. Good job, champs. Add that to 20 pi. Total surface area. Recalculate here. 200.265485 with the little units. Square inches. Okay. Hold on. Don't. Because you're going to get one of these tonight. Are we okay? Okay, you can only calculate what is showing on the outside. Do not count something that's covered up in your surface area. All right, nice job. Even with the little delay of game at the beginning.